So problem number 1 is asking us to name the angle pair, solve for the variable, and find the measure of each angle. So the pictures are not drawn to scale. So looking at 1A, so we see that it's shaped kind of like an L, and there's this box here, which means that it makes a 90-degree angle, and these are called complementary angles. Complementary angles have a sum of 90, so to solve, we're going to add them and set it equal to 90. So it's going to be x minus 13 plus 3x plus 1 equals 90 degrees. And now we solve. So combining like terms, I can combine my x terms. So x and 3x is 4x. And then I can combine my numbers. So negative 13 and 1 is negative 12 equals 90. And now we are going to add 12 to both sides. So I have 4x equals 102. And then the last step is we're going to divide both sides by 4. So 102 divided by 4 is 25.5. So x equals 25.5. Then it also says to find the measures of each angle. So to find the measure of each angle, we're going to take x and we're going to plug it in for x in both angles. So starting with the first angle here, we're going to do 25.5 minus 13, which is 12.5. So angle XY W is 25.5 degrees. And then we're going to plug it into the second one. So 3 times 25.5 plus 1. So 3 times 25.5 is 76.5 plus 1 is 77.5 degrees. So the measure of WYZ is 77.5. It is good practice to make sure, remember that since these are complementary, these two angles should add up to 90, and when you add them, they do add up to 90 degrees. All right, part B. So again, we have an angle pair. So these angle pairs form a straight line. So it's basically like, you can think of it as two slices of pizza that form half of a pizza, or 180 degrees. You can either call these supplementary, or you can call them a linear pair. So to solve for y, these have a sum of 180 degrees. So we're going to add it. 3 plus 4y plus y minus 28 equals 180 degrees. And now we solve. So combining like terms, I can combine my y terms. So 4y and 1y make 5y. And then I have my numbers. 3 and negative 28 is negative 25. And now we add 25 to both sides. So we have 5y equals 180 plus 25 is 205. And then the last step, divide both sides by 5. So 205 divided by 5, you get 41. So y equals 41 degrees. All right, so now once we have that, now what we need to do is we need to plug in 41 for y to solve for the measure of each angle. So starting with the angle on the left, which is angle ABC, it's going to be 3 plus 4, and then in parentheses, 41. So 3 plus 4 times 41, you get 167, so 167 degrees. So the measure of ABC is 167 degrees. And then the angle on the bottom, it's going to be 41 minus 28, which is 13 degrees. And just like the previous one, since you know these are supplementary, these two angles should add up to 180. And if you add 167 plus 13, you get 180 degrees. All right, looking at part C. So these angle pairs are created by, we have intersecting lines and they're opposite angles, or they're across from each other. So these are called vertical angles. Remember that vertical angles are congruent, which means they are equal. So to solve, we're going to set them equal. So 3z plus 5 equals 7z minus 11. This is the one we split down the middle, and then we choose a side for variables and a side for numbers. Remember the side, to make your life a little easier, if you choose the side that has the larger variable to being your side with variables, it'll keep your variable term positive. So first thing we're going to do is we need to move the 3z over, and we're going to do that by subtracting. So then I have 5 equals 4z minus 11. And then we add 11 to both sides. So 16 equals 4z. And now to get z by itself, divide both sides by 4. So we get z equals positive 4. Now we need to solve for each angle, so we're going to take 4 and we're going to plug it in for z on both sides. Remember, when you plug it in, we should get the same angle measurement. That's how we know we solve for z correctly. So starting with the first one, we have 3 times 4 plus 5. So that's 12 plus 5, which is 17 degrees. So the measure of PRS is 17 degrees. And when we solve for QRT, we should also get 17 degrees. So plugging in on the other side, 7 times 4 minus 11, that's 28 minus 11, which is in fact 17 degrees. All right, number 2, now we are just naming a pair of angles. So first one we're looking for is a linear pair of angles. So that's essentially two angles that form a straight line. So here's a straight line. So two angles that form a straight line would be angle 4 and angle 5. Make sure when you are naming the angle, you put the angle symbol. So angle 4 and angle 5 would be considered a linear pair. Now, vertical angles are formed by intersecting lines, and they have to be opposite angles. So for instance, angle 5 and angle 7 are considered vertical angles. So angle 5 and angle 7. Adjacent angles. Remember that adjacent just means next to, so we're just looking for two angles that are next to each other. So for instance, angle 2 and angle 3 are right next to each other. There's nothing in between it except for this ray. So those would be considered adjacent angles. So angle 2 and angle 3. And then complementary angles. So complementary angles form a right angle. So here's a right angle. So the two angles that fit inside that angle would be angle 1 and angle 2. So angle 1 and angle 2 are complementary angles. All right, moving on to the next concept. I can determine angle pairs made only from parallel lines and transversals. So this one we are naming angles and stating the relationship. Remember, here's an important thing to remember. With parallel lines cut by transversals, the angle pairs are only congruent or supplementary. None of these angle pairs are complementary. All right, so starting with number 1, we're looking for alternate interior. So alternate refers to the fact that one is on one side of the transversal and the other angle's on the other. So for instance, 3 and 6, and interior means in between the parallel lines. So those would be alternate interior. The other pair of alternate interior would be 4 and 5. So angle 3 and angle 6 are alternate interior angles, and alternate interior angles are congruent, which means they are equal. All right, B says a pair of same side interior. Same side refers to the same side of the transversal. So these angles over here would be same side. These angles on the right would be same side. Interior means on the inside. So angle 3 and angle 5 would be considered same side interior, and so would 4 and 6. So angle 3 and angle 5. And same side interior angles are supplementary, which means they have a sum of 180 degrees. All right, the next angle pair are alternate exterior. So again, alternate means one on the left, one on the right. Exterior means on the outside. So for instance, angle 1 and angle 8 are considered alternate exterior angles. The other pair of alternate exterior angles would be angle 2 and angle 7. Alternate exterior angles are congruent. All right, last one are corresponding angles is the one that everyone forgets. So corresponding angles are angles that match. So for instance, we have the upper pair and the lower pair. Angle 1 is on the top left-hand corner. Looking at the lower pair, angle 5 is also in the top left-hand corner. So those would be considered corresponding. Angle 1 and angle 5. Corresponding angles are congruent. Another pair of corresponding angles would be 2 and 6, or 3 and 7, or 4 and 8. Those would all be considered corresponding angles. All right, number 4, we're solving for the variable. We're going to show, work, and justify using academic vocabulary theorems. So starting with A, so first we need to figure out what angle pair. These are on the same side of the transversal, and they're both on the inside. So these are same side interior. Remember that same side interior angles are supplementary, which means we're going to solve this, we're going to set it up, adding them. So 4z plus 14 plus 14z plus 4 equals 180 degrees. And now we can solve. So combining like terms first, we have 18z, and then we have 14 and 4, which is 18, equals 180. Now we're going to subtract 18 from both sides. So we have 18z equals 162. And then the last step, we're going to divide 162 divided by 18. We get z equals 9. Then to justify using academic vocabulary, we need to basically state the angle pair and the relationship. So I'm going to say these are same side interior angles. So they are supplementary. So the theorem or the vocab I'm looking for here is same side interior and supplementary. That would explain why we set it up this way. All right, looking at part B. These ones are on opposite sides of the transversal, so they're alternate, and they're on the inside, so these are alternate interior angles. And remember, alternate interior angles are congruent. So to solve, we're going to set them equal to each other. So 7x minus 8 equals 5x plus 10. All right, I'm going to put my variables on the left and my numbers on the right. So I'm going to subtract 5x from both sides. So I have 2x minus 8 equals 10. And then I'm going to add 8. So I have 2x equals 18. And then I'm going to divide both sides by 2. So x equals 9 in this case. And then to explain, to justify, I'm going to say these are alternate interior angles. So they are congruent. All right, part C. These are on alternate sides of the transversal, and they're both on the outside, so these are alternate exterior angles. And alternate exterior angles are congruent. So just like the previous one, we're going to set them equal to each other. So 11x plus 4 equals 12x minus 7. So I'm going to move my variables. I'm actually going to move my variables on the right and my numbers on the left. So I'm going to first start off by subtracting 11x. So we have 4 equals x minus 7. And then I'm going to add 7 to both sides. So I get x equals 11. And we don't need to divide by anything since x is already by itself. In terms of an explanation, we're going to say these are alternate exterior angles. So they are congruent. All right, last one, part D. So these are on the same side of the transversal, however, one is on the inside and the other one is on the outside. So these can't be same side interior or same side exterior. This is the one that everyone forgets about. These are called corresponding angles because they're both in the top right-hand corner of the little group. Okay, so corresponding angles are congruent. So to solve, we're going to set them equal. 8x plus 12 equals 9x plus 1. I'm going to move my variables to the right and my numbers to the left. So first I'm going to start by subtracting 8x. So I have 12 equals x plus 1. And then I'm going to subtract 1 from both sides. So I have 11 equals x. And just like the previous one, I don't need to divide by anything since I already have x by itself. And now I need to write my explanation. So I'm going to say these are corresponding angles. So they are congruent. All right, moving on to the next concept. So concept C are my triangle theorems. So number 5, we're finding the values of x, y, and z, and then we're going to show work and justify using academic vocabulary and theorems. So starting with A, if we look, we see we have two triangles. We have this triangle on the left, and then we have this triangle on the right. So we're always going to start with a triangle with two angle measurements. So that's going to be the purple triangle on the left. So since there are 180 degrees in a triangle, to solve for x, we're going to add 61 plus 43, which is 104, and then we're going to subtract from 180. So 180 minus 104 is 76 degrees. So x equals 76 degrees. So to explain, I need to basically explain where this 180 comes from. So the way we got the 180 is by using triangle sum theorem. So I'm going to write triangle sum theorem states there's 180 degrees in a triangle. All right, so now solving for y, we're going to use the fact that angle x and angle y are a linear pair, which means they have a sum of 180 degrees. So 180 minus 76 is 104. So y equals 104 degrees. And my explanation for this one is we're going to say angle x and angle y are a linear pair. So they have a sum of 180 degrees. All right, lastly, we're going to solve for angle z. So angle z is part of the green triangle, so we're going to use triangle sum theorem again. So solving for angle z, we're going to do 12 plus 104. Which is 116, and then we're going to subtract from 180. So 180 minus 116, we get 64 degrees. So z equals 64 degrees. And our explanation for this is essentially the same explanation that we did for angle x. We're going to say triangle sum theorem states there's 180 degrees in a triangle. All right, let's look at B. So again, B, we have two triangles. I have the triangle up top, And then I have the triangle on the bottom, and we're going to start with a triangle with two angles, and that's going to be the top triangle. So to solve for angle x, we're going to do 25 plus 65 and subtract from 180. So 25 plus 65 is 90. And then we're going to do 180 minus 90, which is 90 degrees. So x equals 90 degrees. Our explanation for this one is triangle sum theorem again. So triangle states there's 180 degrees in a triangle. So this is 90 degrees. All right, so now we're going to solve for angle y. Well, if we look at angle x and angle y, those two angles are formed by intersecting lines and they're opposite angles. So angle x and angle y are actually vertical angles, and vertical angles are congruent. So that means angle y has to be 90 degrees as well. So my explanation for this is angle x and angle y are vertical angles. So they are congruent. All right, last one, we're going to solve for angle z. So angle z is a part of the triangle on the bottom. And that means we can just use triangle sum theorem. So to solve for angle z, we're going to do 90 plus 35, which is 125. And subtract from 180. So 180 minus 125 is 55 degrees. So z equals 55 degrees. And then my explanation is again triangle sum theorem. So triangle sum theorem states there's 180 degrees in a triangle. All right, looking at number 6, we're solving for x and then finding the measures of the exterior angles. So what we're going to use for these ones are exterior angle theorem. An exterior angle theorem states that the sum of the interior angles equals the exterior angle. So to set these up, I'm going to do 26 plus 10x plus 8 equals 14x plus 10. So that's interior plus interior equals the exterior angle. And now we solve. So first thing we need to do is combine like terms. So I have 10x plus 8 plus 26 is 34 equals 14x plus 10. Now I'm going to pick a side for variables. So I'm going to put my variables on the left and my numbers on the right. So I'm going to subtract 10x from both sides. So I have 34 equal 4x plus 10. And now subtract 10. So 24 equals 4x. Very last step, divide both sides by 4. So we get x equals 6. Once we have that, we are going to take x and we're going to plug it in for x in my exterior angle. So 14 times 6 plus 10. So 14 times 6 is 84 plus 10 is 94 degrees. So my exterior angle, so the measure of angle GFP, which is my exterior angle, is 94 degrees. So to explain, I'm going to state the exterior angle theorem. The exterior angle theorem states the remote interior add up to the exterior angle. All right, now looking at B, it's essentially the same type of problem, just with some different numbers. So I'm going to do interior plus interior equals the exterior angle. And we're going to solve. So combining like terms, it's going to be 4x plus 42 equals 12x minus 6. I'm going to put my variables on the right, my numbers on the left. So I'm going to subtract 4x. So 42 equals 8x minus 6. Add 6 to both sides. 48 equals 8x, and then divide both sides by 8. So we get x equals 6. Once we have that, we are going to plug it into my exterior angle. So I'm going to take 6 and plug it in there. So it's going to be 12 times 6 minus 6. So 12 times 6 is 72, minus 6 is 66 degrees. So the measure of angle, and we're going to call this KSR, which is our exterior angle, that's going to be 66 degrees. All right, going on to the last concept, which is the distance formula Pythagorean theorem problems. So number 7 says Juan drew the line segment MN on the coordinate plane, determine the distance between points M and N. So there's a couple ways you could do this. You could write out the coordinates. So we could say that this is 3, 4, and 5, -2, and you can use distance formula. Or you can just go ahead and draw in your right triangle and use Pythagorean theorem. I find that way to be the easiest, so that's what I'm going to do. So looking at this bottom leg, there's 2 boxes, so that's 2. And then this side leg here, we have 1, 2, 3, 4, 5, 6. So now I have my triangle. This is 2 and this is 6, and we are solving for our hypotenuse, which we can call C. It's going to be 6 squared plus 2 squared equals C squared. So 6 squared is 36, 2 squared is 4. So we have C squared equals 40. And then the last step with Pythagorean theorem is to take the square root of both sides. So my exact answer is square root of 40. And then to get my approximate answer, we put square root of 40 in our calculator. And you get about 6.32. All right, number 8. We're given the coordinates, and we want to find the distance between the 2 points. So again, 2 ways you can do this. You can either use Pythagorean theorem or you can use distance formula. So for this one, I'll go ahead and use distance formula just so I can show both ways. Distance formula, remember, is x2 minus x1 squared plus y2 minus y1 squared. So plugging it in, I get so x2 is 3 minus -12 squared plus, and then we have y2, -7 minus 5 squared. Now we're going to simplify the parentheses. So 3 minus -12, 2 negatives turn to positive, so that's 15 squared. And -7 minus 5 is -12. And then we square, so 15 squared is 225. And -12 squared is 144. When we add that together, we get the square root of 369. And when we take the square root, that's a decimal, so my exact answer is square root of 369. And then my approximate answer is 19.21, approximately 19.21. All right, part B, same thing, but I'm going to show you a different method. We're going to do the stack and count. which is essentially just Pythagorean theorem. So we stack our coordinates and then we determine the distance between our x values and our y values. So to go from 2 to -4, we have to go 6 places, and then to go from 5 to 7, we have to go 2 places. Now we're going to use Pythagorean theorem. So essentially this is saying we have a right triangle with legs 6 and 2. So we're just going to do 6 squared plus 2 squared equals c squared. 36 plus 4 equals c squared. This is basically the same as problem number 7. So c squared is 40. And last up, Pythagorean theorem, square root both sides. So our exact answer is square root of 40, and then our approximate answer is about 6.32. So it doesn't matter which way you choose to solve these problems, whatever way works best for you. I find that if you do it the stacking count, I see a lot less errors. All right, problem number 9. It's a word problem, so we need to draw a picture. It says a hiker walks 6.4 miles east. So it might help to draw, here is our direction. So east is basically to the right. So we walk 6.4 miles east, and then 5.9 miles south. We want to know how far away are they from their original. So we have a right triangle like this, and now we're going to use Pythagorean theorem. So 6.4 squared plus 5.9 squared equals c squared. And then we're going to square. So 6.4 squared is 40.96. 5.9 squared is 34.81. And now we add. So c squared is 75.77. And last step, we're going to take the square root of both sides. So my exact answer is square root of 75.77. And then my approximate, we're going to take the square root of that, and we get about 8.70. And then since this is a word problem, we need to make sure we include the units, which would be miles. All right, last one, number 10. We're solving for the missing length. So with Pythagorean theorem, it does help to highlight your hypotenuse. Remember, you can always identify your hypotenuse because it's always across from a right angle. The reason why that's important is because in Pythagorean theorem, the hypotenuse is always by itself. So setting this one up, we have 5 squared plus x squared equals 15. So that's 25 plus x squared equals 225. And then we're going to subtract 25 from both sides. So we have x squared is equal to 200. And then square root both sides. So my exact answer is square root of 200. And then to get my approximate, we put that in our calculator. Square root of 200 is about 14.14. Okay, part B. Again, Pythagorean theorem. 4.1 squared plus 9.8 squared equals x squared. And now we're going to square. So 4.1 squared is 16.81. Then 9.8 squared is 96.04. Then we're going to add. So 16.81 plus 96.04 is 112.85. And then we're going to square root both sides. So my exact answer is square root of 112.85. And then to get my approximate, we're going to take the square root of that in our calculator, and we get about 10.62.